Okay, this short video should hopefully go through the basics of both databases and how we design databases, and covers everything from tables and fields through to queries and normalisation. First of all, what we're discussing here is things called relational databases. These are databases that have to follow the mathematical rules of relations. This means that each row in the table must be unique, and each cell in the table must contain only one item of data. I'm going to explain in a few minutes what a row is, a cell, etc. The way that we access a database is through a database management system. There are three examples shown there: SQL Server or SQL Server, Oracle, and Microsoft Access. The whole point of a database is to keep the data separate from the programs that use it. So therefore, for example, on a mobile phone, you can have a database of contacts which allows you to access that database through your text messaging system, through your contact system, through your phone call system. Each of these three programs are totally separate, yet each of them are using the same piece of data through a database management system. The database management system is designed to allow any program that wants to talk to the data to be able to talk to the data. So the jobs of a database management system are quite straightforward. First of all, it has to maintain data by adding new records, deleting old ones, and amending any data stored in a record, as set out by the user. It has to provide data security, protecting it against unauthorized access and data corruption. This means you can set up a database with a username and password, or you can set a database up so that there are multiple users available, and only certain users, for example, may only have access to certain tables. Handling error situations and recovering from them. If halfway through writing to a database suddenly the power goes out, you want it to be able to cope with that and make changes so that it doesn't destroy all the data that was in it before. It also may have to maintain access statistics for billing purposes. For example, the DVLA, every time their database is accessed by the police to find out a person's details from their number plates, they will actually charge the police some money, so they need to know how many times that database has been accessed. So what makes up our database? Well, let's start with tables. A table is a single entity in our database system and is made up of a collection of records. You can imagine a table as looking like an Excel table, where you've got sort of rows and columns. If that's the case, each row would be consistent to being a record, okay, one piece of information, one object, if you like. This record is made up of different pieces of data. So if you had like a contact database, a record would be the contact details for a person, and each column would hold one item of data. So it would hold like the address line 1, address line 2, town, county, postcode, mobile phone number. All of those are just one data item, and each one of those is known as an attribute or field. You have to make sure that every single record is totally unique. We saw that in our previous item where we were looking at what makes a relational database. So you have to make sure that you can identify something called the primary key. This is a unique field or group of fields that identify a record. Now, hopefully, there should be lots of different things that you can choose from to give your primary key. Each one of these is known as candidate keys, and it's actually up to the database developer to decide what makes up the primary key. In a database system, you need to have links or relations between tables. This is where you can link bits of information to other bits of information. For example, you might have an address table and a telephone table, and you link the address to the telephone for the house number. These tables that involve links require something called a foreign key. This is a key that's a primary key in one table being used to link to another table. This means that there is some data that has to be duplicated. For example, the primary key in one table has to be in a second table as a foreign key to produce a link. So it's a necessary duplication of data, because one of the things we're trying to do with databases is reduce the need for data duplication. So here's our first database table example. This is a single database table. So each of these rows is a separate record, and each of these columns stores one piece of information. Already you can see a problem that comes about when you've got data duplicated in more than one place when that shouldn't be the case. For example, here we've got an owner code here of 1995 Julian Giles, And you've got the same owner code here for a Julia Giles, same telephone number as well. Well, either Julia and Julian live together, which is unlikely being that they should have both have different owner codes even if they're in the same address, or someone has mistyped either Julia or Julianne and the other one is wrong. So what we want to do really, we want to divide this table into two to try and remove this data duplication. How do we do this? Well, we see we've got pets here and owners here. One owner can have more than one pet, but a pet can only be owned by one person. So we have what's called a one-to-many relationship between owners and pets. This means that we want to try and take this table here as one of our primary tables, and we want to make the foreign key of the other table, the one where you can have many people, as the owner code, which is the primary key of the first table. So let's see what this looks like when divided into two tables. As you can see, there is an overlap. This becomes the foreign key because it's the primary key of this table. We have now a table which has no data duplication, and it should have been Julian Giles, not Julia Giles. And you can see Mary Preston was duplicated twice there as well and only needed once now. And then we link the owner to the pet through the foreign table. Sorry, through the foreign key in the other table. So how do we write out databases when we're trying to create them? The notation. Well, these are the simple rules which you can read at your leisure. I'm going to skip through now to an actual example. Here are our two tables, and what I'd like you to do is try and see if you can work out the notation for them before I show you the answer. So again, I'm going to just wait a few seconds before showing you the answer. You can pause the video. And this is the result. So you have a name for each of the tables. They can be called anything you like, but you make sure they're not plural. You have them in capital letters. There's pet, there's owner. Primary key for pet is pet code. Primary key for owner is owner code. And we make sure that those are underlined. And then we just write down the actual elements or fields inside the brackets. Sometimes we need to link tables in a bit more of a complicated way. Here we've got some videos and some people. Now the problem we've got is that one video could be loaned out to many people and a person could take out many videos. So instead of having a one-to-many relationship in some respect, we've got a many-to-many relationship. Now we can't link this with a foreign key, it won't work. So we have to use a different method, and the method we choose to use is a link table. So here we have a table which has both the primary key of one table, the primary key of the other table, and then some extra information as well. And the primary key for this table is member code and video code. Notice I've also added date out as a primary key. This is because some people might like to take the same video out more than once, in which case those two items in themselves won't create a unique record. So that we need all three to create a uniqueness. So first exercise for you then, you need to load up Microsoft Access and create a blank database. And what you're going to do is see what data types are available in Access. Load it up and list them just in a table. So you've got the data type and why you would use that type. There are some extra information that you need to sort of think about as well. What is an integer? How do you think a date time is encoded? And how are floating point numbers stored? Now floating point numbers are a big problem, as you've come across in programming before, hopefully, before doing this course. So because, for example, a number like 16,777,217 doesn't exist in floating point, it changes. Moving on then, how do we actually decide on the best data types to use? The first thing we're looking for is efficiency. We choose a data type that stores in as small space as possible for the type of information that we're storing inside it. So a date time has been specially created to work in just 4 bytes of information, which is much shorter than having to store an entire date as a string. Data types help for validation checking. There's 2 things we need to think about when making databases: validation and verification. Validation is making sure that we've got the correct type of data in a field, whereas verification is making sure that the data is correct. You see this on forms that you get on the internet. For example, when you're filling out a form and you don't put in an email address correctly, you might leave out the @ sign, for example, then the @ sign being missing makes a red star appear near that box and it says, this is not a valid email address. That is validation checking. Similarly, in a database, you might make sure that it's a number field so that only numbers can go in because you want to have a number in there. If you do that and you try and add something that isn't a number, it will throw up an error and say, I'm sorry, you can't add this. Speed is obviously important with data types. If you use a yes-no field and search for a yes term in that yes-no field, the computer actually finds it easier because it's part of the data type than it would be otherwise. It also makes the life a lot easier for the person looking at the database design to actually understand what you're expecting to come up into that database if you can see what data types are needed for each piece of data. Okay, here's some questions to see if you can work it through. What is NULL, the concept of NULL? Why is it useful? It's something that contravenes the rules of relational databases but is too useful to give up. What can we use in place of NULL? And how does access allow us to select whether a field can have null or not? I'm going to give you a few seconds before I give some of the answers to this. Okay, null is the concept of there being absolutely nothing. It's where you have a cell of data which contains no information. It's not the same as 0, because if you've got a number field storing the number 0, that could actually be important. That could be a piece of data, whereas null means there's just nothing in that field. That's why it is useful and what it is, really. So what could we use in place of null? We could have a special character for every number type or every type of data that we could use in place of null, but ultimately that would just be doing exactly the same job that null does, so there's no point in getting into that sort of environment when we could just use null. Access allows us to select whether a field can have null or not. We can select whether this field is required or not. If a field is required, it means you cannot leave it blank, i.e. you cannot use a null value in that field. So, designing a database, there's some other useful items that we need to know about. You should really keep a data dictionary when you design a database, which is basically a list of what's going to be held in each cell of each table. Okay, so you might have things like address line 1. This contains line 1 of the address. That's kind of obvious. But DOB might not be obvious to everyone, especially not an English first language speaker, that might mean date of birth. You can add notes directly into the Access database to keep this data dictionary. Every table has a description property, and every field has a description property, and you can use this to store extra information in. This actually does help other people when they look at your database, especially people when they're marking assignments and work. Your database table should have keys. A primary key isn't just there to make sure that you can understand what's the unique item for that table. A database actually needs that information to help make it search for things quicker. Imagine you've got a textbook and you need to search for all the information, all the pages that contain the word the. Going through every single page, slowly but surely, means it would take you a long, long time to go through it. If you had an index for the word the and a list of all the pages that word appears on and how many times it appears on that page, it would make your life a lot quicker. You just literally go to that page with that index, grab that information, and you've got it. And actually, the database uses that same exact principle. If a database has to be searched by a computer, it has to go through every single record. It just does it really, really, really quickly. However, if you make an index for that system and you create a key, it can use that key and index to find those pages really, really quickly. It doesn't have to go through every single record. And in that way, the database becomes faster. In the sorts of databases students create, where you've got maybe 100 records, 200, 500, that's actually not going to have much of an importance. But when you've got a system something like Facebook, where you've got billions of records, this will make the difference of being able to use a system and not use a system. So now we're going to go on to a complicated concept called normalisation, and it is very, very difficult, so you're going to probably have to go through this more than once. But basically, this is a mathematical system that we can use to automatically create a series of tables with the right links out of one set of data. It's used to try and reduce data redundancy as much as possible. the process goes through several different stages, and there's a lot more stages that we're going to cover here. But for all use in real-world environments and also in education, really, you only really have to go down to third normal form. And I'll explain what this means in a moment. So what are the advantages of normalisation? As I say, it is quite a complicated process to go through. Once you get your head around it, you'll be able to do it without any problems. But getting your head around it in the first place is the tricky bit. The advantages are that they're listed here on the screen. I don't actually have to go through them one by one. Let's get straight into an example. Okay, here we have an unnormalised form, which means that it's just the raw data. Basically, you've been asked to create some form of order system, and you've got the order as being demonstrated here, and what you've got to do is work out how to turn this into a database structure. So the first thing we have to do is identify all the different pieces of data that we've got. We've got an order number, date for the order, customer number, customer's name, telephone number, a whole series of items they've bought on their order, such as the quantity of items, what the description is, item code, unit cost, and the total cost for the order as well. What we're going to do is start off by creating a single database table that fulfills all this and has all this information in it. So to make it easier, I've just listed everything here. So this is the first step of our normalisation process. Okay, so we're going to call our table order, our entity, and these are all the fields of information that we're going to use. Using standard notation, we're going to create it looking like this. And as you can see, order number becomes our primary key because our order number will be unique for every order that is created. So this is our final part of zero normal form. We have now completed it to zero normal form. Now we have to move it through to first normal form. And what we're going to do, we're going to look for groups with repeating data. So if we look back at our database table, if you've written it down on a piece of paper, that would be quite useful. So if you want to just rewind the video slightly, write it on a piece of paper. We have to look and see and say, well, on our order, we actually have like a table which shows how many different items have been ordered. And what we're going to do, we're going to divide this out from our original table. So we're going to give it a name, item order, and each of those items had its own item code, which was unique, so we'll use that as the primary key, and then we'll separate that out from the original table. Now this slide hasn't really come out too well as it's supposed to, unfortunately. I do apologise, but these lines here should be over these elements here. Okay, so this line that's inside forename should be over quantity, that line there should be over unit cost. Actually, what I can do, I'm going to draw new lines. So these lines that are currently going through Word should actually be over these items. The reason for this is what we do is we take our standard zero normal form and we draw lines over the items that make up the repeated group, and then we divide that into a separate table. So now we have two tables, order, that's shown there, and item order. We're not quite finished yet. We obviously need to link these two tables together, so what we do is we take the primary key, which was order number, and add that into our item order table as well. So now our actual primary key for item order is made up of two parts, order number and item code together. It says here, just a bit of an aside, this is known as a compound key, which it is, but it doesn't actually matter. So now we have a link between our tables order and item order via order number, and this is going to be important moving through to second normal form. So just for completion, these are our two tables now that we have in first normal form. So we've now captured all that information that was on that original order form, and we've now got it down into two tables. Now second normal form means that examining that second table we've just created, and if there are any data items, i.e. fields, within that table which only relate to part of that primary key, we need to put it into its own table. So again, we need to look at each field that is not a primary key, so not underlined, and see if it's dependent on just one part of the key or both parts. I've handily highlighted in red and green for you to show you exactly which parts we're looking at. Quantity relates to both the order number and item code, because for a specific order, that's how the person sets what quantity of items they want. Whereas description and unit cost are only related to the item code. No matter which order the item code appears on, description and unit cost will always be the same. So we can divide out our description, unit cost and item code from item order. So as you can see now, we've got three different tables. We've got our order table, which hasn't actually changed as yet. We've got our item order table, and we've now taken out the description and unit cost because they only relate to item code. That's all you have to do for second normal form. But third normal form is used just to tidy up everything which is not directly dependent on the key field. Why is this important? Well, if you look at the order table, there's our order number, it's our primary key. Does the surname, forename, title, phone number and customer number actually relate to the order number? Yes. But is it directly dependent on order number? No, because a customer could have more than one order. Therefore, those items aren't actually directly related and directly dependent on order number, whereas the date and total cost of the order are. This means we can tidy it up and produce a new table, which we'll call customer. And what we'll do is grab all those fields and take them out and put them in that customer field, customer table. So now we have our four tables that make up our third normal form. As it says here, as a database designer in the professional real world, you generally only go to third normal form. You can go to fourth, fifth, and so on, but people don't bother because it just becomes silly. There is still data duplication, as you've seen, but these generally are because you've got to have a foreign key and primary key in some of the tables in order to link them together. There are three different types of relationship we can have between tables, and we've actually covered these as we've been going through. These are known as entity relationships, and the three different types of relationship you can have are shown below. So you've got one-to-one relationships. A rental transaction in a video to the actual video itself is a one-to-one relationship. However, you can have a one-to-many relationship. For example, if someone hires many videos, that's a one-to-many relationship. You can also have a many-to-many relationship. One supplier could supply many videos, and each video could actually be supplied by multiple suppliers. So we've got all this data locked up in our database. How do we actually get out of this database the information that we need? Well, what we use are these things called queries, and they are a really powerful tool in getting the data we want from a database. The standard way now in the world that we live in is something called SQL, which we're going to talk about in a few moments. I'm going to go through that in detail in another set of videos. We use queries to view, change, or analyse data in different ways. For example, we might have a question: who ordered American Gangster? Who bought a CD in the last year? Well, pretty much nobody. And what games are in the same genre as a particular game? As long as we've got the right data stored in the database, we should be able to answer these questions using queries. The main query language we now use in databases at the moment is something called Structured Query Language, or SQL. In the real world, we're moving away from that, this thing called big data, where we have these no SQL databases and no relational databases, and they rely on a series of rules instead of SQL. But what we're going to start with is a simple statement which is called select. This is how we get information out from the database table. SQL only actually has 4 different commands, in all honesty, that we're going to use. Select to select data, insert to add new data, update to change data, and delete to remove data. So with a select query, we can get either information from one table, multiple tables, and combine them into a new table if we want to. Any query we create can actually be saved so it can be used at any time. This is true of any database system. So, just to recap, so it's on the screen as well, SQL stands for Structured Query Language, and it's used in lots of different database systems. The actual SQL statement for select looks like this, and it's pretty much written in English. You start with the keyword select, and then you don't have brackets, but you make a list of all the fields, comma separated, that you want to select from, and then a list of tables. Generally, we only have one table there. I'll explain that in a few minutes. Well, actually, I won't explain it in a few minutes. I'll explain it in another video. It depends if you're watching it in a few minutes or not. Where, and then you can specify some criteria, and then you can specify how to order that information. If you don't specify an order, the database will return the information in the order it was added to the database. As I say, I'm going to go through queries in a lot more detail in another video, so I don't want to go into too much detail at the moment. However, as you can see here, a little bit of information about why we sort information. We've briefly talked about indexing, and again, this slide just really shows you a bit more about indexing to give you a bit more of an overview. And so we've reached the final slide of our video. Again, this is just an index really of indexes, just an overview over what an index is used for in a database. Feel free to use this video as you so wish. There are assignments for my students coming up on my assignment system, and hopefully if you are a student on my course, this will be useful to you in order to fill out that information.